One common task in data analysis involves taking the variables that you have in your data set and combining them in some way to create new composite scores. In this video, we're going to look at some of the basic ways that you can create composite variables by combining your other data in R. We're going to actually use some data that we create right here. I'm going to create a variable called rn1 that stands for random normal 1 with 1,000,000 random normal values. And so because they're random, yours and mine will probably not be exactly the same. They're not the same every time you do them. And now you see I've got over in my workspace a variable called rn1. It's got 1,000,000 values in it. Let's get a histogram of that. And so you see, when you have 1,000,000 values, they tend to fall very close to the original distribution. This is almost a perfect bell curve. Let's get some summary statistics for it. And one of the interesting things is, okay, the mean is very close to 0. The median is also very close to 0. The quartiles are right where we would expect them from a normal distribution. What's interesting about this, and the place you're going to see the most variation, is in the minimum and the maximum. In this, it goes down to about -5 and about +5. That is because this is a normal distribution, a standard normal distribution. That's plus or minus 5 standard deviations. Sometimes you'll get up higher than that. I wouldn't be surprised if you ran this through a few times. Sometimes you got up to 6 or 7 in absolute value. So that's one variable. Now let's get another variable. We'll do the same thing. We'll just create a second variable with 1,000,000 values. That's rn2 for random normal 2. And here's its histogram, very similar. And here's its values. Interestingly, you see the extremes are different, but almost everything else is nearly identical to what we had in the first one. Okay, so now we've got two variables to deal with. We're going to start combining them in a few different ways. One of the most important is to be able to average things. Now, this becomes interesting because R is a vector-based language. And so if you could be writing this, for instance, in C, you would have to write a loop and you would have to write for I equals 0 and ... and go through things one by one. But R deals with vectors by default. And if your vectors in particular are the same length as these are, then it just goes through and it matches the first item in one vector with the first item in a second vector, and it goes all the way through. It makes our life very easy here, because to get the mean, all I need to do is I need to add the two vectors and divide by 2. And that's going to go through one by one. It'll add the first item in vector 1, the first item in vector 2, take that sum, divide it by 2, go to the second item in each, and create a new vector. So I'm going to do that right now, rn.mean. So that's random normal mean. So now you see that showed up in the workspace on the top right, and it also has 1,000,000 values. We get a histogram of that one, and you see that it's very similar. It's symmetrical. It goes to about the same lengths as the other two. That's an easy thing. Now, an interesting one is if you multiply. And what we're going to do is we're going to take the first score in the first vector, multiply it times the first score in the second vector, and so on. Now, there's an interesting thing about this, and that is when you take random data or standard normal variables and you multiply them towards each other, you get a very peculiar distribution that results. So let's get the histogram here, and this one should look different. Okay, do you see what's going on here? It's got a very strong peak in the middle, and it goes way out. Let's see how far it goes by looking at the summary. Okay, the median and the mean are still nearly 0. The first quartile and the third quartile have pulled in. They were originally about 0.67. Now they're about half that. But what's most significant is the minimum and the maximum values, -13 and +12. That's standard deviations. That's very high ends for what we're dealing with here. In fact, the most relevant statistic for this particular kind of distribution is to look at the levels of kurtosis, which have to do in part with how peaked the distribution or how it curves at the bottom. But the thing that affects kurtosis more than anything is the presence or absence of outliers. So let's take a look at these variables and look at levels of kurtosis. Now, to do this, I'm going to need to use a package here. There's one package called moments, because kurtosis is one of the statistical moments. And moments uses the traditional definition of kurtosis, where a mesokurtic normal symmetrical distribution has a value of 3. On the other hand, the package psych, which we've used before, recenters the values so that a normal distribution has a value of kurtosis of 0, just as it would have a value of 0 for skewness. That's more common now, so that's the one that I'm going to use. So if you don't have psych installed, you can install it with this one. I already have it. You can get information about the package by going right here. I'm going to load the package by using require. You can also use library for psych. Then I'm going to start getting the values of kurtosis. For random normal 1, the kurtosis value should be around 0, and it's 0.002. It's really close to 0. For RN2, it should also be close to 0. It's even smaller, 0.008. The average of the two should be close to 0 as well. And it is, negative 0.006. But you'll find the one where we multiplied them is going to be very different. And we get a value of about 6. Now, this is actually similar to something that's known as the Cauchy distribution. It's a very unusual distribution in statistics. It looks like a normal distribution, but it actually has extraordinarily high levels of skewness. And it's actually brought out a lot as a sort of statistical monster because it behaves so strangely. But you can see here, you can start getting an approximation of this Cauchy distribution by simply multiplying two standard normal deviates. Anyhow, that's one way of combining variables. I got two variables here. I showed how to add them, how to average them, how to multiply them. And obviously things like subtraction or division would be very straightforward variations on these. But with these, you can start to get, for instance, scale scores from a survey, or you can get index numbers from archival data. And that's the general idea, to be able to combine the data and get the information that you need from the data that you're able to get.